Hello, the aim of this video is to take you through the process of undertaking a two-way repeated measures ANOVA. Now the participants are completing both trials, so it's a within subjects design. Now we have data here, so obviously each row is a participant and the data here represents the salivary cortisol response to exercise. So two types of exercise were undertaken, an interval session and a circuit session. So you can see on the labels you've got interval and circuits to distinguish between them. If we go to variable view, I've put the data in here, so the names here represent the different subjects, and then you can see here you've got the pre and post salivary cortisol variables for interval and circuits. So going back to data view, these are the variables we want to compare. So we want to look at if there's a difference pre and post exercise, and also the second variable is if you want to see the difference between the trials. So whether the interval session or circuit session elicited a more pronounced response of salivary cortisol. So to set up the test, we need to go to Analyze, then we go to General Linear Model and Repeated Measures, and this box comes up. So we need to input the two factors which we're going to compare. So I'm going to label the first factor trial, so that's either interval or circuits. So there's two trials, and add that one in. And the second factor is time, and there's 5 time points for each trial, so add 5 there. Once you've done that, you click Define, and you can see here a box opens where you can input the variables. So the number 1 represents the trial, so we've got number 1 trial, number 2 trial, and then the numbers in the second part represent the 5 time points. So for speed, they're all in order, so we'll click on the first one, click Shift, select all, and then put them all across. So you can see now the boxes are filled, so all the interval trial is number 1, and all the circuit trial is number 2. We've got all the time points. The second thing you want to do now is just define a couple of things to add to your output. So first of all, go to options. So we want to get some of the means for the trials. So we can actually look to select all of those and display the means. And we're going to compare the main effects as well. So we've click on Bonferroni correction. And that's just going to correct for multiple comparisons of the means when we look at the in-depth analysis of the trial. And you can see here descriptive statistics, we'll click there. And that's what we need to do. So click Continue. And the second thing to do is click Plots. So we want to look at a graph to see both trials in the same graph. So on the horizontal axis, we're going to have the time, and then the trial is going to go on separate lines, and we'll click Add at the bottom. And that will just give us straight away an overview of our data. So click Continue, and that's all you need to do. So click OK. So the test is now running. So here we can see, first of all, we've got the variables that are in the trial, 2 trials, 5 time points. Going down, we've asked for the descriptive statistics, so that's giving us the mean and the standard deviation for each value. So those are the 10 values you've got there. And we'll scroll down to the next thing of significance. So the Mortley's test of sphericity is important because we want to look at the variance between the trials. Now, if you go down to the next box, you'll see a box saying sphericity assumed. Now that's the box we're trying to consider with this Mortley's test of sphericity. So at the moment you can see that the value is significant for time. So that means that the variances between the variables are not equal. So the data is not spherical. So that means what will happen is when we click the next box down here and we're looking at the effects of the time and trial, we need to select the second box, which is called greenhouse Geyser box, and that's basically saying that the data is not spherical. If the value here was not significant, so the p-value was more than 0.05, then we can assume the data is spherical. So you can see here we would take this box for sphericity assumed, and we would use that value. But because it is significant, then we need to assume it isn't spherical. So moving down, you can see that this is the test of within subject effects. So first of all, you've got the trial effect. So this is saying whether there was a significant difference between the two trials. And looking at the second box, that was significant. And the second box we need to look at is time. So again, we'll go for the second one, and there was a significant effect of time at some point in the analysis. And the third thing we need to look at is the interaction effect. Well, this is going to give us an indication of whether there was any significant effect of trial and time when comparing the two trials. So you can see here that this is also significant. So it looks as though there was a significant difference between the trials for multiple points. So that's 0.01. So we move down, and now basically we want to see where those differences occur. So what we did was we did the Bonferroni corrections and more pairwise comparisons. So we're going to scroll down and actually find those. So we start off with trial. So we can see here there was a significant difference between the trials. So that does tell us that the response was different. The best thing to do now is to look down at the plot. So you can see here trial 1 was the interval trial, trial 2 was the circuits trial, and there is a difference between the trials. So this one here looks a lot higher, the response is more pronounced, whereas the circuit trial, there does seem to be an initial increase, but it's not very high. So this is what the data is showing us. So we'll go back up to the actual pairwise comparisons. So there was a difference overall between a trial, and this is always all the means averaged. However, the more significant thing to look at is going to be the time changes. So we're going to look at to see if there was a difference in time. So if we're comparing time points 1 and time point 2 here, you can see the significance was 0.051, so almost significant and a trend towards significance. However, if you look at the other point, there was a significant difference between time points 1 and 4 here at 0.37, and also if you look down, there was a significant difference there was a different trend for time points 1 and 5, so pre and post exercise, 60 minutes post exercise. So that tells us that in one of the trials at least there was a significant effect of time, and given the fact that the trial effect was different, it looks, if you scroll back down, to be that the main effects are coming from this interval trial. So what you would do now is, now you've identified that one of the trials was different and actually there is a time effect, you would run separate one-way repeated measures ANOVA to see where the differences lie in the trials. And it is likely that this trial here, there's going to be some degree of significance between the time points. However, circuit session, there probably is not going to be any significance across this trial. So you will need to do some extra analysis, but then you can identify exactly where the data is identifying the time and trial differences. So this video has summarised how to do a two-way repeated measures ANOVA.